In this question, we have a block of isotropic material which is stressed in x and y directions. And we have the relation between these stresses. In part A, we will determine the stiffness in the x direction. And in part B, we will compare this E prime with the elastic constant E. Let's start. First, we will write our observation. When we look at the figure, we can see that stress in the z direction is 0. So sigma z is 0. So let's start writing the equations. Since sigma z is 0, we will write epsilon x as 1 over E times sigma x minus Poisson's ratio sigma y. And we can write epsilon y as 1 over E times sigma y minus Poisson's ratio sigma x. Let's start with part A. We know that stiffness in the x direction is sigma x over epsilon x. And we can write epsilon x as 1 over E times sigma x minus Poisson's ratio sigma y. As I said in the beginning, we know the relation between sigma y and sigma x. Let's write sigma y in terms of sigma x so that we can make some arrangements in the equation. And we have 1 over E times 1 minus lambda Poisson's ratio times sigma x. And finally we have E times 1 minus lambda Poisson's ratio. Let's move on to the part B. Now, we are assuming that Poisson's ratio is 0.3. For lambda is equal to minus 1, we have E prime is equal to E over 1.3. In this case, we have the stiffness in the x direction smaller than the elastic constant. For lambda is equal to 0, we have E prime is equal to E over 1. And in this case, E prime is equal to E. Finally, for lambda is equal to 1, we have E prime is equal to E over 0.7. And in this case, the stiffness in the x direction is larger than the elastic constant. As a conclusion, we can say that E prime is dependent on the value of lambda. When we change lambda, the value of E prime also changes. And we are done with the solution.